Welcome to another episode of learning. Please like my videos and share them with your friends and colleagues. Please join as a member in my channel and support me and my channel. This is my channel. Please subscribe my channel if you have not already subscribed. Thank you. We continue the discussion of the solutions of the problems that have appeared in the CSIR National Eligibility Test July 2025. In this video, we discuss the solution of a problem from the section Ordinary Differential Equations, and the problem is related to the Sturm-Liouville Boundary Value Problem. And this problem is placed in part B, which is a multiple choice question, and it carries 3 marks. The question ID is 5629541117. Further, this question is suitable for all these examinations. Right. The given question is, let lambda n, where n belongs to a set of natural numbers, be the sequence of eigenvalues of the Sturm-Liouville problem given by d by dx of, in brackets, x dy by dx plus lambda by x multiplied by y is equal to 0, where 1 less than x less than e to the power of 2 pi. Under the boundary conditions, y at 1 is 0, y at e to the power of 2 pi is 0. Then sigma n is equal to 1 to infinity 1 by lambda n, that is the sum of this series, is equal to, we are given 4 options. Option 1, pi square by 12. Option 2, 2 pi square by 3. Option 3, pi square by 4. Option 4, pi square by 16. Right. Let's now discuss the solution of the problem in detail. We are given lambda n, n belongs to n, is a sequence of eigenvalues of the Sturm-Liouville problem given by d by dx in brackets x dy by dx plus lambda by x multiplied by y is equal to 0, where 1 less than x less than e to the power of 2 pi, and the boundary conditions are the value of y when x is equal to 1 is 0, the value of y when x is equal to e to the power of 2 pi is 0. Now, let us take the first term, that is d by dx of x dy by dx, differentiate. We will get x d square by dx square plus dy by dx, yes, after differentiation using the product rule, plus lambda by x multiplied by y is equal to 0. Right. There is a x sitting in the denominator here, so multiply throughout by x. Yes, you can do it because x is greater than 1, x is not 0. So multiply throughout by that, x square d square by dx square plus x dy by dx plus lambda y is equal to 0. Let's call this equation as the equation 1. Right. Observe this differential equation. It is a Cauchy-Euler differential equation. To solve this differential equation, we transform the independent variable x to a new independent variable z by means of the transformation x is equal to e to the power of z, or z is equal to ln x. Yeah, this is a Cauchy-Euler equation. So we change the independent variable from x to z by this transformation x is equal to e to the power of z, and that is z is equal to ln x. Then what happens to dy by dx and d square by dx square in terms of the independent variable z? Then x dy by dx is theta operating on y, and x d square by dx square is equal to theta multiplied by theta minus 1, theta operating on theta minus 1 operating on y, where theta is the differential operator with respect to the new independent variable z. Then this equation 1 now becomes x square d square by dx square is theta into theta minus 1 plus x d by dx is theta plus lambda operating on the whole thing in brackets operating on y is equal to 0. And after cancellation, simplify, we will get a theta square plus lambda in brackets operating on y is equal to 0. Right? It is a second order homogeneous linear differential equation. Right. The auxiliary equation we will write m square plus lambda is equal to 0. Then m is equal to under the square root of minus lambda, that is I under the square root of lambda, and lambdas are non-negative numbers. No problems will come. Then y will be given by C1 cos of root lambda z plus sine 2 C2 into sine of root lambda z. It is z is the independent variable, new independent variable. We will get back. Substitute z is equal to ln x in this. And auxiliary, the complementary function itself is a solution for this, because there's the right hand side is 0. That is this the homogeneous equation. Therefore, there is no particular integral. The general solution is y is equal to C1 cos of root lambda for z ln x plus C2 sine of root lambda for z ln x. Right. We got the solution of the given differential equation. We continue the discussion in the next slide. Right. So we got the GS. Right. To evaluate C1 and C2, we use our boundary conditions. We are given y of 1 is 0. That means in the above, put y is equal to 0 when x is equal to 1. If you put y is equal to 0, 0 is equal to C1 cos root lambda into ln of 1 is 0. Cos 0 is 1. So 0 is equal to C1 plus C2 into sine of ln 1 is 0. Sine 0 is 0. So C1 is 0. So in the above equation, C1 is 0. Therefore, y is equal to C2 into sine of root lambda ln x. Take the second condition. Y at e to the power of 2 pi. So substitute y is equal to 0 when x is equal to e to the power of 2 pi. So y is equal to 0 is equal to C2. You need not worry about C1. C1 is already 0. So C2 into sine of root lambda into ln of x is e to the power of 2 pi. Ln of e to the power of 2 pi is 2 pi. So it is 0 is equal to C2 into sine of 2 pi root lambda. And to obtain non-trivial solutions, we must have C2 not equal to 0. Then sine of 2 pi root lambda will be 0. Then 2 pi root lambda must be a multiple of integral multiple of pi, that is n pi, where n belongs to z. Then root lambda will be equal to pi cancels and it will be n by 2. Right. But that means root lambda will be n square by 4. But lambdas is a function of n. Therefore, lambda suffix n is n by 2 whole square, that is n square by 4. N belongs to n because we are considering the sequence. In the case of the sequence, n is a natural number. So, right, no problems. So, now sigma n is equal to 1 to infinity 1 by lambda n. That will be sigma n is equal to 1 to infinity 4 by n square. That is 4 multiplied by sigma n is equal to 1 to infinity 1 by n square. 4 times the sum of this series. And it is well known that sigma n is equal to 1 to infinity 1 by n square is always convergent. If it is convergent, it converges to what? The sum of the series. It is well known. Sigma n is equal to 1 to infinity 1 by n square is pi square by 6. So 4 into pi square by 6, because sigma n is equal to 1 to infinity 1 by n square is pi square by 6. Okay, after cancellation, it will be 2 pi square by 3. Where is our answer? The answer is appearing against option 2. Therefore, the answer to this question is option 2. That is the detailed discussion of the solution of the given problem from the section ordinary differential equations, which is related to the Sturm-Liouville Boundary Value Problem. It is a simple, straightforward question. I am sure that you have understood the solution of this problem. Thank you for watching this video now. Please like my videos and share them with your friends and colleagues. It is my earnest appeal to all of you is please join as a member in my channel and support me and my channel. This is my channel. Please subscribe my channel if you have not already subscribed. Yes, I am sure I will be meeting all of you once again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.